In this video we are going to solve a numerical related to Porter governor. So we have an example. The arms of a Porter governor each are 250 mm long and pivoted on the governor axis. The mass of each ball is 5 kg and the mass of central sleeve is 30 kg. The radius of rotation of balls is 150 mm when the sleeve begins to rise and reaches a value of 200 mm for maximum speed. Determine the speed range of the governor. If the friction at the sleeve is equivalent of 20 Newton of load at the sleeve, determine how the speed range is modified. So we have a numerical in which the speed range of a governor is to be determined. They have also given radius of rotation of balls is 150 mm when sleeve begins to rise and reaches a value of 200 mm. Means we have minimum radius of rotation as 150, maximum radius of rotation as 200 mm. For this we have minimum and maximum position of sleeve. So for that we are going to draw minimum and maximum position. So we will first consider a arm AB. So as 250 mm long, arms of the Porter governor are 250 mm long. So they are equal and are connected to the spindle. First we are going to draw for minimum position and B for maximum position. So A, B, D for minimum position. So on this rotating balls weight, that is in terms of mg, will act in downward side. Similarly here weight of the center load downward direction will be mg. So for half governor axis it will be mg by 2. This is the height of the governor. So for minimum position we are going to assume it as h1. So they have given arms of Porter governor are each 250 mm long, 250 mm long, 250 mm long. Then mass of each ball is 5 kg. So they have given data mass of each ball is 5 kg and mass of central sleeve is 30 kg. So that is capital M is equal to 30 kg. The radius of rotation of balls is 150 mm when the sleeve begins to rise, means minimum position. So we have 150 mm as minimum radius of rotation. So R1 is 150 mm. Then next, when the sleeve begins to rise and reaches a value of 200 mm for maximum speed. So R2 is 200 mm, means the radius of rotation for maximum position will be A, B, this point will be D. Similarly here, now H2 will be the height of the governor for maximum position. Similarly here, mg by 2 weight of central load will act in downward side. Mg weight of rotating balls will act in downward side. So we have to determine speed range of the governor. So speed range of governor means it is the difference between the maximum and minimum speed of the governor occurring at maximum position and minimum position. So let n1 be minimum speed when the radius of rotation is r1, that is minimum, and to be the maximum speed when radius of rotation r2 is maximum. So we have speed range. So speed range of governor is n2 minus n1. So we want to determine the speed range of governor. So for that we have equation of speed, that is n square when each arms are of equal length. That means the value of q is equal to 1, means tan beta by tan alpha equal to 1. So we have derived the equation, and the equation is m plus m divided by m into 895 divided by h. So h1 will be for minimum position, h2 will be for maximum position. So we have the values of mass of each ball, mass of central load. So the value of height and speed is not known. So either we have to determine speed or height. So we can determine this height by using Pythagoras theorem, because the sides of the arms, length of the arms are known to us. So if we take triangle ABC, so in triangle ABC, if we apply Pythagoras theorem, as it is a right angle triangle, angle C is a right angle triangle, or angle ACB is 90 degree. So we have AB square is equal to BC square plus AC square. So by Pythagoras theorem, AB square is equal to AC square plus BC square. So we have value of AB as 250 mm. So 250 square is equal to value of AC is no known. So AC we can represent it as H1 plus BC is 150 square. So the value of H1 will be H1 square, or H1 will be under root 250 square minus 150 square. So this value of H1 will be equal to under root 250 square minus 150 square. So this value is 200. So the value of height H1 in terms of meter will be 0.2 meter for minimum position. Now substituting the height of governor H1 in equation number 1, we have n1 square, which is equal to m plus capital M divided by small m into 895 divided by H1, which is equal to small m is 5 plus 30 divided by 5 into 895 divided by H1 is 0.2. Therefore n1 square is equal to 5 plus 30 divided by 5 into 895 divided by 0.2. On the root answer, which will be equal to n1 as 176.98, so 177 RPM. Similarly, if we take triangle for maximum position ABC for maximum position, again AB square is equal to BC square plus AC square. So we have AB as 250 square, BC is equal to 200 square plus AC as H2 square. So we have h2 as under root 250 square minus 200 square. So we have under root 250 square minus 200 square. So this value is of h2 is 150 mm. So in terms of meter, h2 is equal to 0.15 meter. So we can substitute the equation of n. So for maximum speed, n2 will be equal to m plus capital M divided by small m into 895 divided by h2. So small m is mass of each ball 5 plus 30 divided by 5 into 895 divided by 0.50. So the value of n2 will be equal to 5 plus 30 divided by 5 into 895 divided by 0.15. So under root of answer will be equal to under root of answer will be equal to 204.369.